Hey, what's up? So now that I got my Workbench controller project completed, what I thought about doing was to see how effective and if the instrument rack heat extraction fans are necessary or not. Because I know a lot of people, for example, have their DVRs sitting inside of a cabinet and they keep the doors closed on them. And I guess, well, they're basically a little PC, and if there's no way for air to get out, the temperature just keeps rising and rising and rising until things go boom. And my buddy works in the cable industry and says that that's actually a really common thing. A lot of people call in pissed that their DVR's locking up, but it turns out they locked the DVR into a closed, like, entertainment center cabinet with no ventilation whatsoever. And then the temperature just skyrockets and then their equipment locks up. So obviously in this case, I know the meter, that bench multimeter, it's an Agilent one. I know that runs Windows CE. Not sure about that. It might not actually run any kind of a formal OS. I think that's also Windows CE. Those don't have an OS. That doesn't. The Rigol on the end might. I don't know for sure. That's the arbitrary waveform generator. But they're not. They're more. Let me think of how to word this. They're embedded OSs. So they're not like a full PC. They're really, really lightweight, and they don't put out too much heat at all. In fact, I think the only instruments up there with fans in them would be the power supplies, both the power supplies, the DC load, and the oscilloscope. I'm not sure about the arbitrary waveform generator, and I'm not sure that the bench multimeter has a fan. I wouldn't think it would need it, but either way, the only three things I can see up there that would put out any significant amount of heat. I know all of them have the potential of producing some heat to some degree, because nothing is perfect, and if it's not perfect, then it's not converting all the electrical energy into whatever you're doing with it, so some of it gets burned off as heat. But I know that there are three things up here that will put out a considerable amount of heat: power supply number 1, power supply number 2, and the DC load. DC load would be the biggest heat generating device up there, because obviously that's basically its job, is to take electrical energy and convert it into heat. To be able to load test power supplies and such, or batteries, or whatever you want to test with it. And then the power supplies, they're not perfectly efficient, and they're pretty high power. They'll both do 30 volts on 2 channels. That one will only do 3.2 amps. That one will do 6 amps. So they're pretty decently high power. So if you're drawing quite a bit of power from both of those, obviously, due to the inefficiencies, some of it will be lost as heat, and then it's kicking that out the back of the chassis through an exhaust fan into the back of my instrument rack cabinet, which goes all the way across there. And it is completely closed off. As you can see, there's no light showing through. But I had enough foresight to put some fans on the top. The layer above there, where all the cables and such are, that only goes back about halfway. So behind that, there's actually like a roof to the instrument rack, and I have 450 or 60 millimeter PWM fans. They're pretty big. There's 4 of them, and I got them wired into my Workbench controller project, which uses PWM to control the fan speeds. I have 3 fan modes. It's silent, optimal, and max. Right now it's on off. This current video right this second is the baseline. I'm going to get the thermal camera, show you that nothing back there has any significant amount of heat. It's all the instruments have been off for a long time. I've got my fluke hooked up to a K-type thermocouple, and then I don't know if you can see the electrical tape from here. I have electrical tape taping the probe, and it goes back about another foot into the back of the instrument rack. It's kind of dead center, just hanging out there in the air in the back, directly behind where the oscilloscope is. And the oscilloscope's actually the least deep device there, so there's plenty of room behind it. There's like an open cavity, but there's a big open area behind all the instruments where the heat can accumulate. But I've never actually done anything scientific like this to actually see how much heat there is and if this is even a big deal. Maybe this was overkill. And maybe other people who might have a similar setup could use this data and potentially save their devices from wearing out earlier than they should due to heat. I know a lot of people have just open shelves that they set their instruments on, and in that case you just have natural convection. It kicks out hot air. The hot air is less dense, it rises, and then it just goes away from your instruments up to the ceiling. In this case, in my case, they're closed into a confined area where you're not going to get, there'll be convection to a really small degree leaking out of there, but it's not going to be enough to get all the heat out of there. Everything back there is going to start to get heat soaked, and could be bad, but I don't know. Okay, so now that we're closer, here's my Fluke 87.5. I have the K-type thermocouple that came with it plugged into it, and that just runs up here. And I taped it so it won't move, so my measurements will be more consistent. But anyways, baseline 28 degrees Celsius on the dot. And then we will open this guy up. That's really hard to do with one hand. Bad design. But as you can see, there is no airflow up here. So this is our no fans, temperature reading, baseline. If any given day, I could come in here and then start working on the bench. This would basically be what I'd be showing up to. Obviously, the temperature is going to be different depending on the day. If it's a hot summer day versus a winter day, if I got the AC on or if it's not, yada yada. But anyways, today's baseline 28. Now it went up to 28.1. But I have the door to the office closed. I usually close it when I do recording to make it more quiet in here, so the microphone isn't picking up a ton of extra noise. But anyways, I guess I could show you too that on here the fan's not going. No, it's not focusing on that really well today. Well, either way, fan off. 28.1, and now I'm going to hook up a load, and then we will let it sit here for 30, 45 minutes, maybe an hour, and then I'll come back and record the second half of this video, and then we'll take a look at the data. I am back. The load tests have been going now for probably, I'd say 20 to 30 minutes. I didn't time it. I should have timed it. It would have been a little more scientific, I guess. But it's been going long enough that I feel that I should probably stop it now. It's getting warm enough that I'm starting to worry. So as you can see, the temperature now is up to 39.5 Celsius. For us Americans, that's 103. Now 103 for semiconductors is no big deal at all, as far as like cooking them. But that's the ambient air in the instrument rack that my instruments are using to cool their internal components with. So you're already taking hot air and then trying to cool your stuff off with it. That's bad news, bears. That means inside of those guys, the temperature is probably considerably higher. So I'm going to go ahead and stop it. But as you can see, I have two test leads hooked up. I just did constant voltage mode. This the basically my method of getting the highest amount of wattage out of there. So what it's drawing is 285 watts, and the wires aren't getting super hot since I went high voltage route versus high current, but they're a little bit warm, and as you can see in this thermal image, they're toasty. You can definitely see them stand out from the background. They're a lot hotter than everything else around them, but they're too thin to measure accurately with the thermal camera. But still, it's pretty cool to see with the thermal imaging camera the wires glowing like that. So anyways, I use this versus this because that only does 3 amps and this does 6 amps, so I have twice the power the Agilent one's capable of doing. I just never use that power supply because it doesn't show wattage where the Rigol one shows volts, amps, and watts. I know it's not hard to do the math, but it's still nice to have that third reading on the screen. So, but Agilent serves its purposes for days like today where I need more power. So, temperature, holy crap, it is still climbing. So yeah, let's go ahead and stop this. And I'm not going to turn the instruments off because I want them to cool off before I shut them off, just for good measure. But let's change it to... nah, actually we'll leave it. Okay, just to show you, again. There's no airflow. The fan is not on. So I'm going to go ahead and turn it to the max setting, and then I'll put the camera on the fluke, and then we can watch the temperature drop. So go to fan mode, max. Yeah, look how fast it's dropping. So that, folks, is why you need to make sure your instruments can breathe and they have proper ventilation. Isn't that incredible how fast it's dropping? But I mean, you have this hot 104-degree air just sitting back there, trapped in the back of the instrument rack. But when you have 450 millimeter PWM fans running at max speed, it cools it right down. I think if I remember correctly, ambient, didn't we start at 31 Celsius, I think? I don't remember. I'd have to check whenever I'm editing this, but for you Yankees, well, I'm a Yankee too, but still dropping. But yeah, and as you saw, I mean, I turned that on for what, maybe 20 seconds, and it dropped down to basically what I remember being pretty much the ambient temperature. So that's all the time it took, which means running in silent mode. Actually, before I change it, let me show you the airflow. Okay, so now you saw just how much air is moving, and it's quite a bit. Okay, actually, I didn't think to do this, but I think I'm going to do it now. Now that the temperature back there is basically back to what it was before we started the load test, I have the fans on silent, which... with my DC load and power supply off. I can't hear it. You probably can't hear it either. The only thing I can hear is my main computer, like rendering station. It's got some fans, but I can barely hear those. But I can't hear the instrument rack fans. But they're spinning. I'll show you. Well, for one, because it's at the silent mode. But I'll actually show you physical proof. No, maybe not. Let's see if optimal mode moves enough air to measure. Okay, well, silent mode obviously is too low to register on my anemometer, but optimal mode, as you can tell, isn't any louder, and it did register like what, 3 miles an hour. Which shows you though the wind speed from when it was on maximum and extremely loud was, what was it, like 5 miles an hour. But as soon as I set it to optimal, which is to my ears not any louder than silent, we were getting 3. So we're getting like 60% of the way there without all the extra noise. So I'm thinking we'll leave it in optimal mode, because optimal to me works fine. If you're doing a load test but you don't want these crazy loud fans going. Well, actually, the DC load and the power supply have loud fans, so it kind of defeats the point of my heat extraction fans being on a quiet setting. But let's go ahead and do the same load test again. I think I'll do it for 30 minutes, and then we'll come back and see if the temperature's moved at all. And if it hasn't really moved, then that'll be testament to the ability of the heat extraction fans to do their job. Which will show you that I guess I've already proven that if you have instruments in an enclosed area like I do, you definitely want some way to get heat out the back. So, and the fans are on the top. They're on the top of the back. So the heat back there should be able to rise straight out between the blades, but even then the convection isn't strong enough to keep it cool back there. If it weren't for the fan holes, and they're 150 millimeter holes, there's 4 of them. The blades aren't that big. There's plenty of room for the air to get out via convection, to rise through there. So I'm sure plenty of it's actually getting out, and even with the air escaping out of there, we still hit 104 degrees Fahrenheit. So let's go ahead and start this again. So total, system's drawing 265 watts at 30 volts, which equates to about 8.8 amps, as you can see over there between the 2 channels. Yeah. Oh, that's what I didn't. Crap. I forgot to show you what the back of the instrument rack looked like when it was at 104 degrees with the thermal imaging camera. I might do it again later. This is just going to take a lot longer than I thought. But anyways, I'm going to let this go for 20 or 30 minutes, and then we will see how the temperatures do. But I'm going to tell you right now, I don't think they're going to move much. Load test has already started. When I did it earlier with the fans off, the temperature pretty much immediately started to rise very slowly. If anything, the temperature is going down. I just saw it go from 30.7 to 30.6, so Celsius, obviously. So yeah, I'm going to let this go at roughly 265 watts for 20-30 minutes. We'll come back, and I have a feeling that temperature is not going to be any higher, so see you in a little bit. Okay, so it's been 30 minutes roughly, and check this out. It's actually cooler than when we started the load test. You might ask how. My air conditioning is on. That could be part of it, but I also opened the door to the office once I started it because it was getting a little stuffy in here. So with the fans going, obviously, if it's kicking the hot air out, it's got to replace it with fresh air. So I think the ambient temperature of the room went down a degree or 2. So that's why it dropped like another degree below where we started. But that right there shows you that if you have fans, even ones that you can't hear, in this case, on optimal, I couldn't hear them. With a 268 watt load test going, we're not getting any significant amount of heat, and everything's staying nice and chilly, so you know that your instruments will be plenty safe back there. So there you go. That is freaking awesome, and that shows you that if you have instruments in an enclosed space, definitely get some ventilation fans and hook them up. And if you don't have a need to do some big fancy controller like I have to control your lights and your fans and all that fancy crap, just get some 5-volt fans. They have fans that run at 5 volts, and then you can just get like a USB charging brick used for charging a cell phone, and then just plug the fan into that sucker, and there you go. I think even one fan would be better than just leaving everything there to cook in just some dead air. So yeah, I thought this could potentially be helpful and maybe save some people's instruments, but I imagine most people probably have open shelves on the wall, so you know the hot air just rises and goes out into the room, so you probably wouldn't have the problem I could potentially have. So but anyways, it's actually still going, as you can see. We will go ahead and stop it. So and I'll let them stay on for a while, so the fans will kick the residual heat out of the system. Yeah, that's it though. Pretty awesome that with the fans on a mode that's basically silent to my ear, sitting right in front of the bench, that the air in the back of the instrument rack is basically, well, I'd say ice cold, but it's ambient. Because if you look here, 84 cents, 4 degrees above ambient. It's 80 degrees in the room, so it's 84 back there. But considering I was dumping, was it 265 watts back there worth of heat from a load test, I think that's pretty damn good. Okay, so this is basically the before shot. As you can see, everything's pretty much the same color. It just shows you. And if you look on the right, the temperature range is really small, meaning pretty much everything in the view is basically about the same temperature. And if you see anything that looks hot, that's just metal reflecting heat. So this is the after shot. Take a look at that heat back there. Isn't that crazy? And as you can see from the, man, I'm really terrible with the camera work. On the right, the top end of the scale basically shows you what the hottest stuff in view is. And for most of it, it's getting up to like above 100, like 100 and, there you go, I just saw 110. This is from the left side of the bench where the load and the power supply both are. I really suck at the camera, sorry. It's really hard to do that. Hold a camera in. I just wish it would record video, so I didn't have to use a camera to record my thermal camera. But yeah, pretty crazy. So anyways, thanks for watching, and hopefully this will be useful to someone out there in the world. If not, it was still fun for me to experiment around with this. So anyways, talk to you later.